104, purpose. Gio, what's today's purpose?
First I will review and take the vocab quiz, then I will learn how phrase a little bit and a little bit on
Relevance, Wes.
This will help me to understand how the calendar is.
And let's see here. Adrian, success.
I'll be given a location on the first day and I would think where there's a number of points.
Okay, so we have our quiz today and we have a homework assignment. Vocab quiz. Concept quiz tomorrow. Here are the words we're going to be using. We have used all of them so far. Main ideas. Let's see here. Michael, for number one.
We made a model of the Earth going around the sun. The big idea of the project was that throughout the orbit, the axis is point in the same direction.
So here in this diagram we have the top of the axis pointed towards the right. Here it's to the right, there it's to the right, there it's to the right. It's always leaning to the right, pointing towards the North Star, which is, something like up there. It's always pointing to the same spot. That means that sometimes it's leaning towards the sun and sometimes it's leaning away from the sun. Okay, Isaac, number two.
Because of this, the northern and southern hemispheres get different hours of sunlight each day throughout the year. The number of sunlight hours gradually changes for both hemispheres.
Okay, so over here, the northern hemisphere is tilted towards the sun, and so we have more daylight hours than nighttime hours. More hours of heating up in the sun, and so it's warmer, and so this would be summer. Over here, the northern hemisphere is pointed towards away from the sun, so we have more nighttime hours than daytime, more hours of cooling than heating up in the sun, and so this is winter. Next, we have the same complicated graph that we've looked at before. Number one, how has the snow cover changed during winter during the time of the graph? Is it steady, consistent increase? Is it up and down but basically increasing? Or is it up and down but basically the same? Circle your answer. We're looking at the top graph here, the top line on this graph. It is up and down, up and down, up and down, and so I'm not going to call it steady. Here, up and down, but basically increasing, up and down, but basically the same. Well, here it's just a little bit below the line of 6, and it gets a little bit above, but then it's a little bit below 6, and it goes up, but it's a little bit below 6, and it goes up a little bit below 6. I'm going to say it's up and down, but basically the same. How many people had that? Raise your hand. All right. Number two. What was the most snow-covered year from this time period? Circle your answer. The time where we had the most snow, well, it's either right there or right there. That's the highest parts of the graph. They're both right around 6.2, 6.3 million square miles. 6.2 million square miles. And let's see here. I'm going to say that was about 1978. And 2010. Number three, is there a pattern to the ups and downs of the graphs? Can you see some kind of a pattern? Analyze them carefully. Circle your answer. Okay, let's have a thumbs up, thumbs down. Thumbs up for yes, thumbs down for no. Let me see answers for everybody. I'm going to start over here. Let me make sure I get everybody's response. Thumbs thumbs up for yes, there is a pattern. Thumbs down for no, it's random. What do you think, Jayla? I would say that there really isn't a pattern at all. I would say no. It looks like here there's a pattern for the first few years of spring, up down the same amount at a steady rate, but then it falls apart and it doesn't continue. So no. Number 4, a researcher claims that if summer has lots of snow cover, then the entire year will have a higher than average amount of snow cover. If it's high in the summer, it's going to be high in the other graphs too. Does this graph support or refute that claim? Put down yes or no. Let's look at this part right here. Here there's a high part of the summer. It has lots of snow cover in summer. And in the fall and the spring and the winter, it also peaks up a little bit. Is that true all over the place? Here we have lots of snow in the summer, but in the fall, they did not have much at all. Here in the fall, it was lower than the adjacent months and years, and same thing here. So, nope. Number 5. To the left is a graph that covers part of the same data during some of the same time as the above graph. Does the data agree? Wow, that's teeny tiny print. I don't know if I can read that. Can you read those dates on the bottom?
Yeah. Yes, sir.
What's the first date here?
I can go from the right side over.
From the right side. Okay, Wes, what is that number?
2010.
This is 2007? 2010. Okay, 98765, is that how it goes?
Yeah.
So 2005, 43210, 98765, 43210. Thank you very much there, Wes. Okay, so 1990, it goes from here to 2010 here. It's that part of the top graph is mimicked down here. Does the data in these two places agree?
Yeah. No.
Note that this is winter, so we're going to look at the top graph, starting from here to there. Okay, so it goes down, and then up, and then down, and a little bit of a peak, and then down some more, and then up, and down, and up, and down, and up, and then way up. The general shape is the same. Let's look at the numbers now. The numbers here are all right around 6. Uh-oh. That's 6 million square miles. But this is showing 16 million, 17 million, 17 million, 18 million. How could those numbers be so different? Anybody see it? This is 6 million square miles. This is 18 million square kilometers. So, that's the reason why they have different numbers. They're using different units. Okay. But otherwise, yes. What was the big idea of the Daylight Project, where we spun small globes at different points in the orbit? This is the tilt results in different amounts, different hours of daylight. What was the big idea of the flashlight? Let's see here. How would we say this? Let's say the different angles heat differently. When we had the flashlight at straight up and down, it concentrated its energy on one small circle, so it could heat up that area well. But when we had it at an angle, it spread out the energy over a wider number of squares, and so it heat up the ground less. What was the big idea of the clay model project? The axis is pointed at the North Star all year. It's always tilted in the same direction towards the North Star. Okay, so we're now going to review for the vocab quiz. You either do the crossword puzzle at the top or you do the double blank activity at the bottom. The answers, once again, the words are right here. So if you want to tear off this sheet to make it more convenient, go ahead and rip it out. Do either the top or the bottom. When you're done, tell me about it. I'll check you off, and then we will take the quiz.